So this is Ravinder working as assistant professor in the Department of Computer Science and Engineering, IARE, Dundigal, Hyderabad. Today, we are going to discuss about TensorFlow. TensorFlow is an end-to-end open source platform for developing and deploying machine learning models. It is a core open source library to help you to develop and train machine learning models. It has a comprehensive, flexible ecosystem of tools, libraries, and community resources that lets researchers push the state of the art in machine learning and developers easily build and deploy machine learning powered applications. A brief history about TensorFlow. TensorFlow, developed by Google Brain, it is released under Apache 2.0 license in the month of November 2015. The current stable version of TensorFlow is API 1 version 1.14. TensorFlow has more than 18,000 developers over the world. Why TensorFlow? TensorFlow has been a platform of choice to offer developing and deploying machine learning applications for lots of organizations in the world. So if you have studied the basics of machine learning techniques, it's right time to learn practical machine learning with TensorFlow. In this TensorFlow, we can develop a regression model, a boosted trees, and a deep neural network model with the TensorFlow. By using TensorFlow, we can explore underfitting and overfitting machine learning models. At scale up TensorFlow model with a large amount of data to distribute training. It supports machine learning productions anywhere in the world. For example, servers, web, edge devices, irrespective of a platform or language used for training building. Once you learn this TensorFlow concepts, the framework, you should be able to code machine learning algorithms with the TensorFlow and also understand how to scale up to work with a large amount of data. Overview of the TensorFlow. TensorFlow is basically a software library for numerical computations using data flow graphs where edges in the graph represent multidimensional data arrays called tensors. So these tensors communicated between them. So please note that tensor is the central unit of the TensorFlow graph, and whereas nodes represent mathematical operations. For example, the TensorFlow, the given diagram, in that TensorFlow, the TensorFlow contains two words, tensor and flow. So tensor represents a multi-dimensional array and the flow represents a graph of operations. Internally, TensorFlow implements machine learning algorithms as a graph of operations on multi-dimensional arrays. Tensor is a data structure. Consider the given below diagram here, which has one node and three tensors. Here, add is a node which represents addition operation, and A and B are the input tensors, and C is the output tensor, also called as resultant tensor. So it is a flexible architecture, allows you to deploy computation to one or more CPUs or GPUs in a desktop, server or mobile devices with a single API. Tensors are used as the basic data structure, the TensorFlow language. Tensors represent the connecting edges in any flow diagram called data flow graph. Tensors are defined as multidimensional array or list. Tensors, we can identify tensors in a TensorFlow diagram by using three parameters: rank, shape, and type. Now coming to the rank of TensorFlow, rank it is a unit of dimensionality described within the tensor, and it identifies the number of dimensions of a tensor. A tensor rank in a tensor can be described as the order. So various dimensions of tensors: one-dimensional tensor, two-dimensional tensor, etc. Now coming to the one-dimensional tensor. One-dimensional tensor is a normal array structure which includes one set of values of the same data type. For example, here by using that np.array, we can create these many values of the same type: 1.0, 1.9, and 4.0, 23.99. So this tensor ID, so this one is what a tensor just now we created. Now if you want to print this tensor on the screen, we can use the print tensor ID. So tensor ID is the tensor. And coming to the two-dimensional tensors. A two-dimensional tensors is a sequence of arrays are used for creating two-dimensional tensors. The creation of two-dimensional tensor is described below. Now here, by using this one, np.array, here 1, 2, 3, 4 is one tensor, 4, 5, 6, 7 is another tensor, 8, 9, 10, 11 are a third tensor, and 12, 13, 14, 15 as another, the fourth one-dimensional tensor. That means we are combining four one-dimensional tensors to create a two-dimensional tensor. Now if you want to display this two-dimensional tensor on the screen, so just use the print command. So output like this. We'll see this output on the screen. Now, if you want to identify a specific element of a two-dimensional array, two-dimensional tensor, so we can use index concept. For example, here, tensor 2D, 3, 2 means what? 3 and 2. 3 means what? Third tensor, third one-dimensional tensor, and 2 means what? In third two-dimensional, third one-dimensional tensor, and 2 is the second element of the third one-dimensional tensor. So these are the various dimensions in the tensor data structure. Any TensorFlow core program can be divided into two discrete sections. First of all, we have to build the computational graph, and second, we have to run the computational graph. So actually, to evaluate the nodes, we must run the computational graph with the sessions. So we have to create a session by using session ID, so we can run the computational graph. Now this is one first TensorFlow program to understand the basic concepts. Now here, first of all, we have to import a TensorFlow framework into our program as a TF. And first of all, we have to, as I told, we have to create a computational graph. A computational graph, it consists of what? A number of tensors and nodes. Nodes represent operation, and tensor represent dimensions, arrays. Now here we have created three tensors: node 1, node 2, and node 3. So these three are tensors. Node 1, node 2 are input tensors, and node 3 is a resultant tensor. Now TF constant 3 is the value, and by using D type we can represent type of that constant. And node 2 also is there, so we can create a second tensor by using TF dot constant. The value is 5. The value is 5, and D type represents the type of that value. And that last one, resultant tensor, its name is what? Node 3. So here by using add method, we can run the computational graph. So as I told already, first of all we have to create a computational graph, then we have to run. So tf.add, which that means what, we can run the tensor, computational graph. So with help of two nodes, with help of two tensors, we are giving two tensors to the node which receives the input by using two sensors and do some operations and give the output to the output resultant tensor. Now before run the tensor, the computational graph, first of all we have to create a session. So by using session, we can create a session. By using tf.session, we can create a session ID. So with help of that, we can run the computational graph. So this is the output on the screen, you can see. So we have sent 3 and 5. We can send 3 and 5. 3 plus 5, 8. The answer is 8 on the screen. So in the above code, the nodes, node 1 and node 2, we created by using tf. Constant. So both are constant type. Yeah, these two are constant type. We pass the values 3 and 5. Node 3 is the third resultant tensor. So by using add, we can add the values of two tensors. So this method, which takes the tensors as input and returns their sum as output tensor, that is node 3. So this is now I am concluding this TensorFlow concepts.
Like, share and subscribe. Hit the bell icon for more updates.